We are beginning parallel line proofs today, and there are two main types of parallel line proofs. Parallel line proofs like number 2 here, where we know that the lines are parallel and we're trying to find a relationship in the proof. So that's the first type. We know the lines are parallel because it's in the given. And we'll spend a couple of days on this idea. And then the second type, we are trying to prove the lines are parallel. So it would be in the prove in that case, parallel, sorry. So there are 5 new reasons that we can use in parallel line proofs. The first one is if the lines are parallel, then corresponding angles are congruent. If the lines are parallel, then alternate interior angles are congruent. If the lines are parallel, then alternate exterior angles are congruent. If the lines are parallel, then same side interior angles are supplementary. And then the other new one that we will eventually talk about is called parallel transitivity, which says if line A is parallel to line B and line B is parallel to line C, then A is parallel to C. So it's similar to regular old transitivity, but regular transitivity, plain old transitive, is congruence. Parallel transitivity says the lines are parallel. So we're still going to be using regular old transitive a lot. This one we will only see once or twice. So the first step in being able to do a proof is being able to recognize the angle types and write proof reasons in single steps, and then we'll put them into a proof. So it says if line AB is parallel to line CD, what is the proof reason for each statement? So we want formal proof reason, one of these. We also still have vertical angles are congruent, linear pair postulate, and all the ones we learned in the previous chapter. So if we look at angle 1 and angle 6, those are vertical angles. So we write vertical angles are congruent. To be vertical, you do not need parallel lines. So there is no if parallel for this or linear pair postulate because there is no requirement to have parallel lines for these to be true. These will be the only ones that have the parallel at the beginning. 3 and 8, we're talking here and here. Those are corresponding angles. So if the lines are parallel, then corresponding angles are congruent. 4 and 8, this guy and this guy, are alternate interior. Now if you don't like all this extra stuff going on, just cover it up with your finger. Okay? Cover over what you don't want and just focus on 4 and 8, and those are alternate interior. So if the lines are parallel, then alternate interior angles are congruent. 3 and 10 are on the outsides, on opposite sides of the transversal, so those are alternate exterior angles. And then finally, angle 4 is supplementary to angle 7, that's this one and this one. Those are same side interiors. So if the lines are parallel, then same side interior angles are sup. So this needs to match what this said. This says congruence, this says congruence, and so on. Now, once we are able to identify those and write them in a formal proof reason, now we can begin to help or work through a proof. So the first proof says line A is parallel to line B. In these proofs, we are going to put the givens in as we use them. So I am not going to put all the givens in step 1. And the first thing it's important for you to understand in these proofs is that we will not be required to convert to congruence unless we're using substitution or supplementary. So only convert to congruence. to equality. If using supplementary somewhere in the proof, that's the only time we'll convert to equality. So we are not going to convert this right off the bat like we did in the previous chapter. We can continue to do the wordy statements, and parallel counts as a wordy statement. So we've got to undo this wordy statement and figure out what that means. So think of this as your frog. We're trying to prove that the frog can jump from angle 1 to angle 2. Now, if you look at the picture, the frog cannot directly jump from angle 1 to angle 2 because he has to jump along a single road. So he can't do that because that would take 2 roads to get there. What he can do, if line A is parallel to line B, and you do need to label that, is that your frog can jump from line A to line B. So if your frog jumps from line A to line B, and we want our frog to start here, so he's doing a trip. The beginning of his trip is angle 1. By the end of the trip, he should be at angle 2. So if we jump from line A to line B, you can jump from 1 to 3 because they are corresponding. So the postulate says if the lines are parallel, then corresponding angles are congruent. Therefore, 1 should be congruent to angle 3. So there are lots of places you can start, but you definitely want to start with either angle 1 or angle 2 because those are the ones in the proof. And it's good to start here if you think about the frog making a trip. So we know angle 1 is congruent to angle 3 because of parallel lines and corresponding angles. Now we're going to bring in our second set of parallel lines that is also given, which will now allow us, I'm going to mark these parallel, to make a jump between line C and line D. So if we make a jump from line C and line D, now we want to link these together. So if he jumped from 1 to 3, he's now sitting at 3. Where can he jump from angle 3? So if he jumps from line D to line C, he can say 3. That is possible because 3 and 2 are corresponding. So 3 would have to be congruent to angle 2. So angle 3 is congruent to angle 2 because if the lines are parallel, then corresponding angles are congruent. So the frog jumped from 1 to 3 because of corresponding. He jumped from 3 to 2 because of corresponding. So he's finished his trip. We just have to link these together. So if 1 is congruent to 3 and 3 is congruent to 2, then basically they both share the 3, so we throw that out, which leaves us with 1 is congruent to 2. Now it looks similar to substitution, but since it's incongruence, that would be a transitive step. Congruence is transitive. If it says equals, then it's called substitution. So we're done with that. So the key is to get the frog to jump from angle 1 to angle 2 using the parallel lines that we have and the information. Let's try another. Number 3 says it is given that P is parallel to R and 1 is congruent to 3. So we are going to start with the wordy statement, parallel, and then we can also deal with this wordy statement, at the end. So we're still using we the people eat pizza. If you don't know what that is, you can find that on my channel as well. But basically it means we're going to start with the wordy statements, and there are 2 wordy statements, one at the beginning and one at the end. We want to undo those. Now I'm going to wait on this for a second and undo this wordy statement. Supplementary simply means that if I add the 2 angles together, I will get 180 degrees. And that is true because definition of supplementary. So we can undo that wordy statement to figure out what it means mathematically. Now here are the angles that we're working with. In the proof, we want to somehow find a way for our frog to jump from 3 to 4. So we are going to start here. It's not the only place you can start, but it gives us something to do. So we're going to start at angle 3, and what is it now? There are different ways that we can do this. So actually, I think we'll back up let's not do that wordy statement yet. Well, we are going to do that wordy statement. We're not going to start from angle 3, so let's get rid of that. If our frog can only jump from P to R, and that's the only jump he can make, then if we look at line P, the only angle there is 1, and on line R, the only angle is 4. So what is the relationship between 1 and 4? That's the only jump we're allowed to make between line P and R. So it's like, since Q is not parallel, he's not allowed to land on Q. Okay? He's got to jump right over it. So 1 and 4 are same side interior. So angle 1 would be supplementary to angle 4, because if the lines are parallel, then same side interior angles are supplementary. So we know 1 is supplementary to 4. Supplementary, or same side interior angles, is similar to perpendicular. It's a high maintenance step because it requires 2 steps to get out. So if we're going from parallel to saying that they're supplementary, we still now have to undo this wordy statement and say what supplementary means. Measure of angle 1 plus the measure of angle 4 equals 180. So that is definition of supplementary. Now we can see where we're at. 1 and 4 equals 180, 3 and 4 equals 180. So you're asking yourself, what's up with 1 and 3? If we look at the diagram, they're marked congruent because it's in our given. So step 4 is to bring that other given in here, which will then allow us to put 3 in place of 1. There's only one problem. These have to agree. They either both need to be congruent or both need to be equality. We can't convert this to congruence, so this one needs to be converted to equality. The measure of angle 1 equals the measure of angle 3 by definition of congruent angles. And now that they both agree, we can take that 3 and put it in place of that 1, so that would be substitution. And so since I worked backwards, I have this little gap in the middle. That's okay. Doesn't matter if we have a gap there. Okay. Let's try the next one. Again, these proofs can be done different ways. I'm just trying to think of the best way that makes sense. So if you find another way, it could possibly be correct. All right, so in this proof, we are given that line AS is parallel to line BT, and we're trying to prove that ray SA bisects angle BSR. Okay, so we've got 2 wordy statements. We've got a parallel line wordy statement. We've got a bisects wordy statement. So we look, SA bisects BSR. Now we're not allowed to mark it in our diagram, but if SA is cutting BSR in half, then angle 1 would have to be congruent to angle 2 by definition of angle bisector. Now, this gives us a goal. So it's as if this was given to us in the proof, and now we have a place where we can start. Our frog needs to jump from 1 to 2, and so we begin at 1. So there are lots of things you can say if these lines are parallel, but this at least gives us a starting point. So if we look at these 2 parallel lines, what can we compare angle 1 to? We can jump from this parallel line to this parallel line and say that 1 and 4 are congruent, because if the lines are parallel, then corresponding angles are congruent. Now the other given I have not labeled in the diagram, so that needs to be labeled. So if I use this wordy statement to find 1 and 4 are congruent, now I can bring my other given in. Okay. And once I have 2 congruent statements, I can create a new statement. So I'm going to put those together, and you throw out the 4's because they have that in common, and use a transitive step to say angle 1 is congruent to angle 5. So our frog has jumped from 1 to 4 and from 4 to 5, so he's at 5. We're trying to get to angle 2. So what could we say about 5 and 2? So that would be our final jump. So we could say angle 5 is congruent to angle 2 because they are alternate interior angles. So if the lines are parallel, then alternate interior angles are congruent. So now I have these two statements. Let's put a box around these two. Once I have two congruent statements, then I create a new congruent statement. Again, they both share the 5, so we can drop out the 5s and say 1 is congruent to 2 using a second transitive step. And now we're at our proof. Okay, so it's all about jumping that frog from 1 to 2. 1 to 4, 4 to 5, 5 to 2, and completing that journey